Okay, in 13.1 we're going to finally get to treating sine, cosine, and tangent as actual functions. And I think it's important at this point to kind of remind ourselves what the heck a function is, right? A function is simply some kind of rule, if we can call a function f, right? And we input some x into the function, and the output is f of x. Right, so a function has an input and we get an output, right? And easy example, something like f of x equals x squared plus 3. If that was our function, f of x equals x squared plus 3, then if we were to plug in, say, 6, right, we would get out 6 squared plus 3, which is 39, okay? So then the question becomes, all right, that's our idea of a function. How does that relate to the trig ratios, sine, cosine, and tangent? Well, what we're going to do is say, hey, what if f of x equals the sine of x, or the sine of theta, or whatever variable we want to give to the angle measure. Okay, that's kind of what we're building up to, treating sine of x, cosine of x, tangent of x as functions. So that's reminder number 1. Here's reminder number 2. In the last week, we started plotting angles as rotations from the positive x-axis. So something like this here, this was a 45-degree angle. Okay, and we also talked about this idea of coterminal angles, that I could go around in the other direction, and let's say in this case I go around negative 315 degrees, and I end up in the same spot. So 45 degrees and negative 315 degrees, those are coterminal angles. Okay, and what does that mean? Well, let's say we'll call this alpha and this angle beta. Okay, if alpha and beta are coterminal angles, then, for example, sine of alpha equals sine of beta. Okay, and of course cosine of alpha would equal cosine of beta, and tangent of alpha would equal tangent of beta, right, and so on. Okay, so here's the idea. Okay, let's not even look at like an opposite rotation. Let's look at, let's say, something like this. And let's say we have a rotation of 110 degrees. Okay. Well, I also know that whatever, sine, cosine, tangent of 110 degrees will equal some value. And if I go all the way around and then back to 110, so 360 plus 110, that would be 470 degrees. Okay. So that angle is also coterminal, and I would get the same value, right, for sine, cosine, and tangent of 110 as I would for 470. Well, I can even go around a third time, right? I can go 1, 2, and back, okay, and add another 360 to this to get, let's see here, that'd be 5 plus 3 would be 8, so 830, okay, and so on. And I can keep doing this. So the idea here is that the functions repeat themselves. Sine of 110 equals sine of 470 equals sine of 830, and so on and so on and so on, right? Every 360 degrees it repeats itself. We say that these functions are periodic. Okay? That means after some set length, the function just repeats itself. Okay? And that's true for if I started at 45 degrees and went another 360, I'd be back to where I started. Another 360, back to where I've started. Okay, so that's big idea 2, setting us up here to talk about sine, cosine, and tangent as our circular functions. So what we're going to do is we're going to look at what we call the unit circle. And I know some of you have looked at this before in the past. Some of you haven't. That's okay. The whole idea here is that if we want to look at sine, cosine, and tangent of any particular angle, remember that these are ratios. So if I call this theta and I ask for sine of theta, well, that's just going to be the opposite angle over the hypotenuse, right, which is in this case 1/2. Now, if this triangle was bigger, let's say the hypotenuse wasn't 1, if it was 6, right, well, that would make the opposite side length here 3. It would make this 3 root 3, right, using my 30, 60, 90. This is a 30, 60, 90 triangle. And I can say that sine of theta in this example, whoops, is equal to opposite over hypotenuse, which is 6, and that equals 1/2. And again, right, same thing. Because remember, sine, cosine, tangent, they're ratios, right? They're ratios. So the size of the triangle doesn't matter because these are similar triangles, and we're going to look at, when we look at sine or cosine or tangent, we're looking at the ratio of one side to another. So it'll divide out to the same thing. So what we like to do, the unit circle, is basically saying, okay, well, consider the case where if I draw an angle, the hypotenuse is always 1. So here we go. I'm going to draw a 60-degree angle, right? And the hypotenuse, the radius of the circle, which is also the hypotenuse of my reference triangle, is 1. Now, if I know that the hypotenuse is 1, and we've kind of done this in the past, then I know that my short leg is the square, or sorry, 1/2, half the hypotenuse. And I know my long leg is the short leg times the square root of 3, so root 3 over 2. Okay? And then we can say, great, all right, from here I can say things like sine of theta or sine of 60 degrees is equal to opposite over hypotenuse, so root 3 over 2 divided by 1, which is root 3 over 2. I can say cosine of 60 equals adjacent over hypotenuse, 1/2, and so on. The big thing, the next step we're really going to take is to say, okay, let's now consider the XY grid, or the XY axis, where the horizontal axis is theta, and the vertical axis is y equals sine of theta. And say, okay, and well, let's see, we'll mark this off, and we'll call this 30, 60, 90, 120, and so on. So every 2 is 30. 150, 180. Okay, and we're going to go through this process, and we're going to do this in class, but just to give you an idea here, and say, okay, well, let me go back up here and erase this triangle. Okay, sine of 30 degrees. Let's say I want to know when theta equals 30, what's the y value, the sine value? Well, I can draw my 30-degree reference angle. The hypotenuse being 1, the opposite being 1/2, the adjacent being root 3 over 2. Sine is opposite, so 1/2 over 1. So when theta is 30 degrees, sine is 1/2. Let's make this 1, so sine is 1/2. Okay, and we just said earlier that when sine is 60 degrees, or sorry, when theta is 60 degrees, sine of 60 is root 3 over 2. Root 3 over 2, well, let's just go ahead and do that. That's about what? Square root of 3 divided by 2, 0.866. So when sine is when theta is 60, we'd be a little higher, kind of up here. Oops. Now the 0-degree angles and the 60 or the 90-degree angles we've talked about a bit in the past. So let me remind you too that we can look at this point as being in this example root 3 over 2 1/2. Right? The y value is always the sine of theta. So if I rotate this point back down here, right, rotate my angle, whoops, that was a little too much. Right. So right here, this point is 1, 0. Okay, so sine of theta when the angle is 0, this point on the circle, the angle is 0, the y value is 0, so sine of 0 is 0. So we get that point. If I were to rotate up the circle, okay, this point here is 0, 1. So sine of 90 degrees, the 90-degree angle, right, is still the y value, which is 1. So sine of 90 is 1. And what you see is we'll go all the way through, and what we'll end up getting is a graph looking kind of like this curve, and it'll continue down through 360 degrees. And that produces our sine wave, y equals sine of theta. Right? And we'll do this for all three, sine, cosine, tangent. We'll create these graphs based on plugging in different values for theta, and we'll produce the graph sine of theta as a function, right? And as I said earlier, they're periodic, meaning that once we get one wave, the wave just repeats itself, and it kind of keeps going on. So we'll do that in class. We'll kind of walk through it step by step and graph out each of the three different functions by hand to really get an idea of how it works.